Hello, everyone! We're on to chapter 2. And here we go. So, what we need to do in order to be able to fully write the equation of a polynomial or any sort of anything is understand this. This is the complex conjugate pairs theorem. And what this tells us is that if there is any sort of complex root, so like an I, a radical 2, its conjugate is also going to be a 0. So if 3 plus 5i is a 0, that means 3 minus 5i is a 0.
Yep.
It's that exciting, people.
Remember, the conjugate is just the change of the sign in the middle, not the constant in front, just the middle sign changes.
Right, the 3 stayed positive. It was the sign in the middle that changed. So let's use this. So let's find the equation of a polynomial function with the real coefficients that satisfies the given conditions. So we know that it's 4th degree, and that 1 is a 0 with a multiplicity of 2, and 2 minus I is also a 0. Okay, so let's think.
I got this one.
Okay.
Ready? Positive 1, so I know it's going to be x minus 1, and it's going to be quantity squared, or I'm going to write it twice.
Whichever way makes more sense to you. We're just trying to show it out here with the multiplicity of 2. Now, you've got to be careful. So if 2 minus I is a 0, that would be x minus 2 minus I, because remember, it's you subtract the factor. It's the opposite of the root. Okay, so with the conjugate pairs theorem, so that's just me distributing it out.
Yep.
Okay, with the conjugate's pair theorem, it's going to be x minus 2 plus I. So this minus stays the same. Okay, and then this in the middle of the 2 and the I, that's what changes. Now up here, it's going to look like 2 plus I was the original almost, and then 2 minus I, but notice that this minus was the same because that first sign didn't change. The reason that I circle 4th degree is, remember, if it's 4th degree, it should have 4 roots. If you stopped here, you're missing a root.
Yep. And there you go.
And that's it. If we don't say standard form, that's it. You do not have to go any further.
Nope. All right, find the equation of the polynomial function f with the real coefficients that satisfies the given conditions. So we want a 5th degree polynomial, and they give us a beautiful looking sketch. And 1 plus 3i is 0. So looking at the sketch, you can see that you have a root at -2, so there's that. And then we have 1 at 1, and it has a multiplicity of 2 because it bounces back. Oh, look at that.
Had to get my boop in.
Had to get her boops in. And then if we have the 1 plus 3i, you're going to do x minus the quantity.
So the negative distributes.
And then you have the conjugate pair, so 1 plus 3i's conjugate pair would be 1 minus 3i.
And then again it distributes. So 1, 2, 3, 4, 5. Fantastic. But there's more. It says that satisfies the given condition. Notice, hey, they give us some other pieces of information right here.
Let's solve for that A, baby. They gave us the y-intercept, the point, 0, -40.
Real coefficients.
So that
we
means
need to find that A value.
So we're going to plug in 0, -40, 0 for x's, -40 for the f of x or the y.
So 0, 0, 0 for the x, etc.
Doing the math. Boom, boom, boom.
You don't have to
Pause
show that
if
you
you
don't want to.
need to write it down.
Yep. So basically here we're just subbing all in. Here you got to be careful. You have to double distribute here. Okay, this is math you should know how to do. We're just pausing to remind you that right here.
First,
you
outside,
have to
inside,
double
last.
Distribute, excuse me. Okay, and then here you get -2. And then my suggestion is if you are using pencil, instead of rewriting this entire thing out, just go right back up here, erase that A, and put your -2 in and circle this guy up here.
Yep. So
Just
always
save
be
yourself some time.
aware. If they give you like an extra point, they want you to solve them for an A value.
Yep, it's not going to say it necessarily. You're going to have to know because it's supposed to satisfy all the conditions they gave you. All right, the other thing we're going to talk about is really, really easy, but it is a thing that we have to talk about. It's called the intermediate value theorem. And all it means is that if you have a output that's negative and an output that's positive, a 0 has to be in between those two.
And she was output is y value.
Yes.
So if you have an x value with a y value that's negative, and then you go a little further and you have an x value with a positive, you know that that thing crossed through the x-axis.
There's no other way to get from here to here without crossing. Okay, so we use this so we can approximate where an irrational 0 could be. Okay, because we don't necessarily know, so it's like an approximation. So really we just need to be able to talk about it. So if we were to use it to show that it has, explain why it has a real 0 on the interval 1 to 2. So we would substitute 1 in, we would substitute 2 in, it's this easy, and 3 and -8. So then you would say it has a real 0 between 1 and 2 because according to the intermediate value theorem, the graph of the function must cross the x-axis.
Boom.
Like, it's that easy. You
Yep.
just show that there's a positive output and then a negative output, and then that means that in between those two, there has to be
a zero.
a zero.
And you'll have to explain a little. So, you have the different signs of the y values so you know that they crossed. And according to the intermediate value theorem, you could get really technical on it.
Yep. I mean, this is basically full points right here.
Mm-hmm.
Okay? That's it. So have a wonderful day, and we'll see you in class.